Hi guys, welcome back to my videos about programming in Go. In the previous part, which is part 3 of an introduction to web programming, I had shown you how to use JSON to format output of a web server. In particular, how to marshal or convert from a Go struct to JSON, and how to unmarshal or decode from JSON back to a Go struct. In this part, I will explore a few existing services with JSON interface, and will show you how to write a Go program that uses one of those JSON interfaces. There are many existing web services that provide a JSON interface. Those web services allow you to make an HTTP request and return the desired information in JSON format. Two examples of web services with JSON interface are the web comic XKCD and the Open Movie database. To access the JSON interface of the web comic HKCD, for example, you just make a request at the URL hkcd.com/571/info.0.json. By typing this URL into a web browser, then it will return a detailed description of comments number 571 in JSON format. The JSON-based web service of the Open Movie database let you search by making a request to the OMD pi.com domain for a movie by name and download its poster image. It will respond with a description of the current API abilities and upcoming REST functions. Note that a RESTful API is an architectural style for an application program interface or API that uses HTTP requests to access and use data. Here is the XKCD web commit. It currently shows a commit with the ID number 3136. Let's click on the permanent link to this commit. If you want to view the information of this commit in JSON, you just add info.0.json to this link and press enter. Then it returns the information of this commit in JSON. And this is the Open Movie database that provides OMDP API, which is a RESTful web service to obtain movie information. If you scroll down, you can search for a movie by title. For example, let's search for Mission Impossible and click search. Okay. And then it returns the information about the Mission Impossible movie in JSON. And let's search for another movie, Swagger. Okay, so it also shows the information of that movie in JSON. However, this JSON format is not user friendly. If you make a request to this URL, with swagger.json in the path, then it will return the JSON objects containing information about the API corresponding to the Swagger movie. This JSON format is with indentations, so it's easier to read. In this lecture, we will focus on another web service with JSON interface. This web service is called GitHub Issue Tracker, which allows you to search for issues reported on GitHub. To perform searches for issues on GitHub, you can make a request at api.github.com/search/issues, followed by a query with a parameter q. The value of parameter q is a search query, which is a string of search keywords and quantifiers. A query can contain any combination of search quantifiers supported on GitHub. The format of the search query is a list of search keywords followed by a list of quantifier. For example, to search for unresolved Go bug on a Windows platform, you can use the following query, where the search query has one keyword Windows and three quantifiers. The quantifier labels :bug indicates that the issues being searched are the bugs. The language :Go indicates the Go programming language. The state open quantifier indicates that the issues are unresolved. Note that in the format of a search query, the keywords and quantifiers are separated by spaces. But when we embed the search query in a URL, the spaces are replaced with the plus signs. You can see the search on GitHub page at this link for a complete list of available quantifiers, their format, and an example of how to use them. So this is the link available at the time of the recording of this lecture. So this is the complete URL to search for unresolved Go bugs on Windows platform. When you enter this URL into the address bar of a web browser, the GitHub issue tracker returns the search result in JSON format like this. The result includes the total count of all issues found, information about whether the search results are incomplete or not, and the list of issues. Items is the JSON array in which each element is a JSON object containing details of an issue in the search result. The main purpose of this lecture is to show you how to write a Go program that uses the GitHub issue tracker. Then the user can run that Go program with search terms as command line arguments instead of typing it into a web browser. The program will display only a few fields from the JSON output in a more user-friendly format. To write such a program, we will use a non-standard package named GitHub, which provides a Go API for the GitHub issue tracker. It was published in the module go pl.io/GitHub chapter 4 or ch4/github. And the package consists of two source files named github.go and source.go. Both of these files are available at this link. Now we will go through the source code of github.go in the GitHub package. In the first part of github.go, it defines a constant named issue URL. To store the URL we have to use to perform a search for issues on GitHub. Here we only store the domain and the path of the URL, not the query string, which will change. Then it defines the struct named issues search result, which consists of two fields corresponding to the total count and items in the JSON output. In the second part of github.go, we define two more Go structs, one for the issue and one for user. The struct for the issue includes several fields that corresponds to details of each issues on GitHub, including the issue number, the HTML URL that describes the details of that issue, the title of the issue, the state of the issue, whether it's open or closed, and the user that reports that issue, and the time where the issue was created, and the body which describe details of the issue. And in the user struct, there are two fields. One is the login string, and one is the HTML URL of that user. In the source file source.go of the GitHub package, it defines the function search issues, which takes a slice of string as argument and returns a pointer to issues search result. Recall that issues search result is a struct defined in the github.go package GitHub. This function also returns an error object. This is the definition of function search issues. Its purpose is to query the GitHub issues tracker. The argument terms of this function represents a list or slice of search terms, which includes search keywords and quantifiers. So first, we call function join from the strings package to combine all the search terms in the terms slice into a single string, using a space to separate two consecutive search terms. Then we pass the resulting string to the query escape function of package net/URL. Recall that function URL dot query escape converts the given string into a query string that is safe to be placed in a URL. So the spaces will be converted to the plus size. Then we concatenate the issue URL constant, the string question q equal, and the resulting query string to build the complete URL for the search. The complete URL is then passed to the http.get function, which will send a GET request with the given URL. As usual, we will check if the http.get has a non-null error. If so, the function returns null pointer and the error. If there's no error with http.get, we check the status of the response that http.get returns. If the status is not OK, then the function returns a null pointer and the error with the error message saying that search query failed and the status. Note that we must also close the body of the response before the function returns in any execution path. If the response status is OK, we create a streaming decoder using function new decoder in the encoding/JSON package. The streaming decoder is of type decoder, also defined in the encoding/JSON package. Then we call the decode method of the streaming decoder to populate variable result, which is declared to be of the issues search result struct. We will learn more about Go methods later. The decode method call returns an error object, so we also need to check if the returned error object is not null. If there's no error, we return the reference to variable result as a pointer to issues search result and return null for the error. Now we are ready to write our program named issues.go that uses the GitHub package. The GitHub package is imported in line 13 of this code. In the main function, it first calls the search issues function from the GitHub package. Recall that the search issues function only takes a list of search terms as the argument. Our program allows the user to enter the search terms as arguments on the command line, so we use the os.args slice to get those search terms. This program then print a table of GitHub issues matching the search terms if there's no error from the search issues function. If there's a non-null error from the search issues function, then the program calls function log.fator to print out the error message and terminate the program. To run the issue.go program, we first build it and then type the program name followed by a list of search terms on the command line. The program name is issue, and this list of search terms is the same as the one we used in the URL to search for unresolved Go bugs on Windows platform. This command was run on the command prompt on a Windows computer. If you run this program on a Mac OS or Linux computer, you need to add / before issue. So that's the end of the lecture. After watching this video, you should be able to give some examples of web services that provide JSON interface and write a Go program that uses one of those web services. Thank you for watching, and I hope to see you again in my next video in the series about an introduction to web programming in Go. Thank you.